Okay, so welcome. So I'm your instructor, Alan Kirkman, and it's, as I said, really nice to see you all. So this is a new experience for me. I was on a sabbatical in spring, so I was not pivot. I didn't teach in the spring at all, so it's all completely new, and I've learned a lot about all this technology, but I'm sure everything's not going to be perfect. Um, but I hope that we'll get to know each other and that you'll get to know the other people in the class. I hope you'll really make an effort to do that, um, because we want to learn the material, but this is Wake Forest. We do want to try to build some kind of community. This is not just an online course that you could watch videos anywhere. And I would say I am open to suggestions, and I will actually be um, handing out some anonymous surveys, probably weekly for a while, um, just to get your opinions on how things are going and suggestions of how to use our time. So we have these 3 75-minute classes, and we can do this sort of any way you want. The way I'm planning on doing it, and when we can change things if this doesn't work, but I'm planning to have introductory videos, and I want them short. It's always the case that they turn out to be longer than I think they're going to be, um, but just a short introduction to the material. And then I'm also giving you, I've written out PDF notes on the material. And I've done that partly because I have found when I'm in Zoom sessions, a lot of times I have a hard time taking notes. So, I mean, you can take notes, but I didn't want you to feel like you had to get everything down instantly because it is kind of all in the notes. I'm following the textbook, but I'm not doing everything in every section. So, so the notes, are a summary of what I'm doing in the section. Then I've assigned homework problems. So those are problems that you should work. I'm not collecting those problems. In some cases, we'll work on those problems in class. And then on Mondays, there's an assignment that you will turn in on the Friday. So those are the problems that'll be graded. Let me just say right off the bat, I will do a better job if I get response. So please, like, interrupt me. So, maybe we should so I was going to do a little introductory tour of everything. So I assume you've all Zoomed before, but if you have not, so notice that when you scroll down to the bottom of your screen, among the things you have is a button that's called Participants. And if you click on that button, I mean, you'll see the names of everybody that's here, but at the bottom, there's things like raise your hand. So I may or may not see that, but that's one way to get my attention. But don't feel shy about just like interrupting me. I don't like talking to nobody with no response. So please, I'm happy to be interrupted. I'll do a better job if I am interrupted. Then there's also the reaction. You can put your thumbs up. That's another way maybe to get my attention. I'm working with 2 computers, so I can see sort of your faces here, and then I'm going to be working on the tablet that's down here. That's why I'm on twice. Right now, you just see, well, maybe my hand at some point. That's going to be the screen that I'm going to write on as a tablet. I don't know, does anybody have any questions about Zoom? We'll look at Canvas next, but let's see, I want to get rid of that. Get rid of the participant. I don't want to do that. Let's see. There, I got rid of the participants. No questions on Zoom, everybody's. And as I said, I hope you'll leave your video on so that you each can get to know each other. I will also use some breakout groups. So that's another way that you can get to know each other. Okay, so let's make sure you also know, I don't know if you've been to the Canvas site. Okay, so here's the Canvas site, and I'm in student view. So I am supposedly seeing this the way you would see it. And so I would say, if there's things that don't work, tell me, because I mean, I'm learning things all the time. Like when I published the course, I found there were some things that didn't get published that I had to actually individually publish. So I have a lot of stuff here. So first of all, this opening video, or this opening picture, is it's an illustration of what linear algebra is about. It's about solving simultaneous linear equations. So here there actually are 3 planes. So those are linear equations. And you can look at where they intersect. So if you look at 2 of them, they're going to intersect in a line. If you look at all 3, they're going to intersect in a point. So this is a visual image of solving linear equations simultaneously. And that's where we start in this course. So I have my email address, and I'm on the computer a lot. Of course, many of you are in China, and so during the day, it's the night here, so I'm not on. But email me. You can also, if you're in the States, if you phone me, that's my office number, but I get the messages on my computer. And so that's also a reasonable way to get a hold of me. So I've reminded you where when our class meets. That link will get you to these Zoom meetings. So we'll see how office hours work. I have no idea. I just don't want to sit on the computer waiting for people to come. So I'm happy to schedule appointments, which may work better. But maybe I'll have too many people because I've just scheduled this room for these 2 hours. And I know these are not great hours for people in China. So this is not the only time I'm available, but there's another Zoom location for those, and that location is there. The course documents. So this first one is basically my syllabus. That's a PDF file. If you click on that link, then there's the course schedule. So we'll see if we can follow it, but I've worked out a daily schedule for the whole semester of what we'll be covering. And then there's this document that the department prepared on preparing documents. So when you turn things in, they've got to be readable. I mean, you can't just take out your camera and take a bunch of pictures and send me 15 files that are JPEGs. I don't want to see any JPEGs. Because I just can't read them. So they need to be PDFs, and they need to be in one file. And so this document has some instructions. I mean, it's not the only way to do it, but it's some ways of doing it on lots of different platforms. So try it before you actually have to have an assignment to turn in. Try that you can actually do, that you actually know how to do this. On your camera or whatever to get the file in the right form. And so for our tests will be in class, and you'll have 75 minutes to do the test, and then you'll have another 15 minutes to actually get it in. So you need to be able to do this, relatively quickly. So then I have these links to the videos. So these introductory videos, I'm going to post here. So I had my getting started video, and then I had a video on the material I'm going to do today. Each day I'll post this introductory video under 15 minutes, hopefully closer to like 10, just sort of giving the highlights so you sort of know what's coming. And then I will be, right now I'm recording, and so assuming I know how to do this correctly, I will post the links to the recordings, and they'll have a password, and I'll put that there. I will also, the board that I'll be writing on, I can convert that to a PDF, and I'll post that here as well. So then the course is set up in modules by chapter. And so this is the getting started, which hopefully, you know, you've looked at. These are just the same things. Here they're actually, you know, documents. I mean, you can read it here. If you had the other link, it would be a PDF file that you would download. So it's sort of, it's a little different. And so this is where we're starting. So with linear equations, this is chapter 1. And so I've got an overview of the chapter. So this is the section I'm going to talk about today, 1.1. This is my introductory video. Again, it's a little bit weird. I don't know why. I tried, you know, but to get the video, you have to click on this top thing. I don't know why it won't do it. It's just very, sort of very, very, well. So let me get back to Canvas. Well, I got to get out of student view, leave student view. Okay, let's go back to student view. Let's go back to chapter 1. Okay, so I have my introductory video. So here's the PDF file of the notes. So this is what I'm talking about today. It's again got the homework assignments here and so on. And you could download it up at the top if you wanted. And so you could follow along in that. Let's see if I can go back. So I'm also using these 3 blue, 1 brown YouTube videos they're very nice. They're animated and they illustrate the main concepts in the course. And for some reason, these links actually, it actually links to the YouTube. I have spent a lot of time trying to figure out why I couldn't get the others to do that, but. And then I've listed every day what you should do. So I'm wanting, and many of you have done this, started to do this, do an introduction so that everybody gets to know you. So that's a link to that page. Here's again, that's just the same list of problems. And again, those are problems that if you want to know what I expect you to know, you know, what are the typical problems you should be able to do, those are the problems. I'm not going to collect those problems. Okay, so going back, what else is here? So you can see the people in the class. And as I say, I hope you'll get to know each other. So then there's another Zoom. So this again has all those, it's the same thing, but you could join the meeting from here. And I also believe, we'll see, but I think the recordings may be here. Anything else? Question? Somebody have a question? Okay. Okay. So any questions on, I mean, you understand how to get to Canvas, how to use that site. That's where you'll be turning in your assignments. No response. Okay, I hope I'll have some questions. It's going to be, we'll go in some breakout groups and work problems at some point. Okay. So how are we doing for time? Maybe, why don't we, actually, we've got enough time. Why don't we, I don't know if we briefly could introduce each other. Let's try. So I'm going, the participants list, which it's probably not organized the same for everybody, but let me go down and just unmute yourself and just say a word about yourself. So starting with Alex.
Um, Hi, I'm Alex. I'm a senior. I'm from Michigan.
Great. Where in Michigan, Alex?
Like the southwest kind of corner of the state.
Okay.
Like if you, best way to explain it is if you went like straight across the lake from Chicago.
Okay. So I grew up outside of Detroit, so I'm a
Okay.
Michigander as well.
What city?
Um, Royal Oak.
Okay, that sounds familiar actually. Slightly. Okay.
Yeah, that's where I went to high school. Okay, Andrew.
Hi, my name is Andrew. I'm a sophomore and I'm biochem major.
Great. And uh, Bixing. I'm not probably too good at pronouncing it, but Bisheng Hung.
Beichen. Yeah, I'm Beichen, and I'm from Nanjing, China, and I'm a biomolecular biology major, and I'm currently in quarantine, so I'm staying in the hotel.
I see. So you're actually in Winston Salem, but they're quarantining you probably in part because you've come
No,
from abroad.
I'm currently back in China, but in the quarantine hotel. So
Great. Good to see you. Andrew Tijan. Andrew. So on my screen, he's right next. So Andrew in the last, yeah, there you are.
Yeah. I have already introduced myself. Do you?
Right, but not, can you introduce yourself to the class?
Oh, yeah. Hi, my name is Andrew. I'm a sophomore and I'm a biochem major.
Great, welcome, Andrew. Let's see. Let's see, Blue Lan.
Yes, here. Hi, everyone. My name is Blue, and I'm a sophomore. I'm currently staying in China, and I major in psychology. I play tennis.
Great. So Bruce.
Hey, I'm Bruce, and I'm from Shanghai, China. I'm a sophomore this year, and I'm thinking of getting into the business school, but not so sure about it. I love sports.
Great. I don't know if we're gonna, supposedly we're gonna have sports. They're apparently still on. We'll see.
Yeah.
Blue.
Wait, are you saying Blue?
Blue Lan.
Yeah, I think I have just introduced myself. Do you want me to repeat again?
Why not? Because I didn't remember that you had introduced yourself.
Oh, sure. Oh, okay. Yes, my name is Blue. I'm a sophomore. I'm currently staying in China, and I want to major in psychology. Yeah, and I play tennis.
Great.
Okay.
Let's see, Chloe Wang.
Hi, I'm Chloe, and I'm a sophomore, and I'm staying in China this semester. I want to major in stats and finance, probably.
Great. So Christian Bernard.
Hi, I'm Christian. I am a sophomore and I want to major in chemistry, and I am currently outside of Subway.
That's great. Drew.
My name is Kevin, and I'm majoring in stats and accounting. I'm currently in campus right now. I'm from Beijing.
Okay. Let's see. There's.
I'm Drew, if that's who you're asking.
Yeah, that's why I was looking for Drew. These names, they bounce around. That's okay. That's okay.
I'm Drew. I'm from Durham, North Carolina. I'm a junior.
Great. Let's see, Emma?
Hi, I'm Emma. I'm from New York. I'm a freshman, and I'm thinking about majoring in either history or poli sci.
So, so are you here in Wake?
Yeah, I'm at Wake.
Great. So Irene?
Hey, I'm Irene, and I'm also a sophomore, and I'm from Beijing, China. And right now, I'm at my home.
Great. So we've got two Jacks, Jack Nemikolas.
Yeah, it's Nemekis, but that's me.
Nemikis, okay.
It's Lithuanian. Yeah. I'm Jack. I'm from north of Chicago. I'm a sophomore, and I'm hopefully going to be a mathematical business major.
Great, great. So the other Jack Sanders.
Yeah, I'm Jack. I'm from South Carolina. I'm a junior, and I'm an econ major.
So Jason.
Hey, my name is Jason. I'm from New York, and I'm a freshman this year. I'm on campus.
Great. So Jiwen.
Hi, I'm Jawan. I'm in Shanghai and I'm a junior. I major in business and computer science.
And so Kevin Zhao.
My name is Kevin, and I'm a sophomore. I'm majoring in stats, and we're majoring in accounting, and I'm currently in campus right now.
Great. Thank you, everybody. So that I will get to know you. And so I will come to the Zoom classroom early. I've got another class afterwards, so I can't stay late. You know, come to my office hours if you want to chat some other time. I know that's not a great time for people in China. Let me know, we can set up some other time. But I'm happy just to chat with you. And be patient with me as I try to master this technology. Okay, what happens? Great. That is good. Okay. Okay, so maybe let's do some linear algebra. Share. Okay, so as I say, if you've got questions, let me know. Maybe I will just turn on my light. That'll make it easier for me. So we're looking at section 1.1, which is on solving linear systems. And this is kind of just the first part of this. We'll get a little more detail on how to do this in the next section. And so, I mean, I hope so you probably know what a linear equation is. So it's something like 2x plus y plus z equals 5. Okay, and so what makes it linear? So there's no squared terms, there's no cross terms. So you just have these variables. Like here they're x, y, and z, but they could be x1, x2, x3, or u, v, w. I mean, they don't have to be, the labels are irrelevant. And then you have coefficients. And so these are like the coefficients. There'd be like a 1 here, a 1 here. And so then this is this, right, you know, what I call the right-hand side. And so it's a little bit different, you know, than the coefficients. So we have the coefficients. And then we have the right-hand side. Okay, so that's one linear equation. And so in 3 space, if we're thinking of x, y, and z as being 3 space, that would represent a plane. So that's just one plane, but we're looking at, so the systems means that we're solving a system, you know, a system. We've got more than one. So in my example, so then I might have 4x minus 6y plus z equals -2. So there's another plane. And those two, if they're not parallel, they'd intersect in a line. And then if I make a third one that's actually different, I would be like in the picture on our homepage of 3 planes intersecting, and they would intersect in a point. And so a system, I'm trying to find the x, y, z that satisfy all of those simultaneously. And so, I mean, you did things like this in high school, and you might not have done it too systematically. I mean, you might like add the first equation and the third, and that would get rid of the x. Or you might multiply the first one by -2 and add it to the second, that would get rid of the x. Or maybe you would try to get rid of the y, and so on. We're going to do this sort of more systematically. And so the first thing we're going to do is just, the variables are just placeholders. And so instead of the equations, we're going to have a matrix, and all a matrix is an array of numbers. So I'm just taking the coefficients and the right-hand sides. And so this is a matrix. And so this is a 3 by 4. So in general, we have an m by n matrix. So that's an array of numbers, and the first number tells the number of rows. So here I have 1, 2, 3 rows, and then the second number is the number of columns. And sometimes when we do this, we put like a dotted line here just to kind of indicate that these numbers here are the right-hand sides, so they're a little different than these other numbers. And so this particular matrix is called the augmented matrix of this system. And if I were to ignore the right-hand sides, I would have the coefficient matrix. And sometimes we'll want to look at the coefficient matrix, not this augmented matrix. But when we're solving it, we want actually the whole thing, this augmented matrix. And the point is, instead of just manipulating the equations, we can manipulate the rows of this matrix. And so the way we'll do that is using what are called, let's get this, elementary row operations. Okay, so those are ways of combining the equations that don't change the solution set. I mean, so for example, if I multiplied out an equation by 0, I've changed the solution set. So you want to do things that are reversible, that don't change the solution set. And so there are 3 kinds. Of row operations. And let me list these things in the way I wanted to do this. So the first kind is interchanging rows. Okay, and that obviously does not change the set of solutions, because you're just changing the order in which you've listed the equations. You know, if you have the first equation and then the second equation, and then instead you make the second equation the first equation, it's still the same solution set. So that's let's emphasize that we want the same solution set. And certainly interchanging rows is not going to change the set of solutions. The one we use the most is the so-called replacement. And that's this combining equations. And so technically what that is we take a constant, say times some row plus some other row, and we put that in row J. Not in row I, but in row J. And the reason we do it this way, and this constant, if the constant's 0, I haven't changed anything. But whether the constant is 0 or not, this is reversible. So if I did this, I could reverse it by just doing this. So the point is, I haven't changed the solution set, because when I do this replacement, I could get back the other equation by just doing this. And then the third thing is scaling. And that's multiplying by a non-zero constant. If I multiply by 0, I'm going to change the solution set. Now everything satisfies it. But if I multiply by something that's non-zero, obviously I can reverse that by taking the inverse. So these are not going to change the solution set. That's the important thing about these operations. And I should say this third one, if I were to put this in row I instead of row J, and the constant is non-zero, it's not an elementary row operation, but it's a combination of two. And so this is the fact that I put this in row J is important just in calling this an elementary row operation. When we talk about determinants, if I were to put this in row I, it would change the determinant. So that's why I want to be careful about where I put it. Although if I put it in row I, it would still be a combination of these as long as the C was not 0. Okay, so in this, so the idea though is to do this in some kind of systematic order. And so in this particular example, so we started with, and I should say this is, because this is an algorithm where you know, once you make a mistake, your computations are going to be wrong. And I should say that most people's mistakes, including mine, are in the recopying. And so right now I'm going to do one thing at a time, but it is helpful if you can do, at least it's helpful for me if I do not as much recopying as I could, because every time I recopy, I'm liable to make a mistake. Okay, so there's lots of things I could do, but kind of the way we'll be sort of doing this systematically is I would take -2 times the first row plus the second row and put that in the second row. And that's to get a 0 in that position. So I recopy very carefully the first row. That's where I'm apt to make my mistake, because I'm typically not thinking about that. I'm thinking about the computation, and if I make a mistake there, everything will be wrong after that. And so then what I'm going to get is 0, and you check me. I'm working from my notes, so I'm probably doing it right, but I can do it wrong. So that's what I would get. And so now I have a 0 there, and I could just recopy this. But again, I'm not going to recopy that third row because that's where I'm probably going to make my mistake. So the next thing I would do is I would take row 1 plus row 3 and put that in row 3. And that's going to give me a 0 here. So that's 0, 8, 3, 14. Okay, so it's getting to be easier to solve because I've eliminated x basically in these last two equations. And now I'd like to eliminate y here, and so I can do that by adding the second equation to the third equation and putting that in row 3. And so that would be 2, 1, 1, 5. here's my, my copying. That's what I'm trying not to make a mistake at. And so now I'm going to add those 2 rows. And the point is that now I have a system that's easier to solve, right? Because I could, what this system is, so this last equation is 2z is equal to 2. And I mean, I can just solve that. And then the next equation is minus 8y minus z is equal to minus 12. And I know what z is. Let's do it here. So I've got minus 8y. Z is 1. So that's going to tell me that minus 8y is equal to minus 11. And so y is equal to 11 over 8. So I've got, and you see this triangular structure is making it nice to solve. And so now if I want to solve for x, this top equation is 2x plus y plus z is equal to 5. But I now know y and z. So it's 5 minus y minus z. Y we said was 11/8. Z we said is 1. And so this works out to be 21 over 16 if I've done this correctly. Okay, so the point is to try to systematically solve this so that we get a triangular system like this so that we can solve it easily. And so this form is called row echelon form. Okay, the row echelon form is going to be easier to solve. This process of this substituting is called, let me use all my colors. This is this back substitution. Right, because I went back. I started with Z, so I'm sort of, the back substitution is going like this. That's why we sort of call it back substitution. So instead of that, you could reduce the matrix further. To something called reduced row echelon form. So you could do more operations, like I could divide here by 2, and then I'd have a 1 here, and I could get rid of the 1 that's right there. So reduced, and we'll talk about this next time more systematically. So reduced row echelon form. And so that's where you get more zeros. And in this particular case, I guess it's in the notes here. So in the notes here, I actually work through each of the operations. And so it becomes 1, 0, 0. I guess, yeah, I could have just taken my solution, right? Okay, so this is called reduced row echelon form because, I mean, I've completely solved for these variables. I've got zeros all above them. And so this avoids back substitution, but it's really equivalent to back substitution. I think I actually make fewer mistakes when I back substitute than when I do the, go further to get the reduced row echelon form. Okay, hopefully everybody, you're so quiet. Let me know if you've got questions. So these matrices so if you have a matrix and you do elementary row operations, they're of the 3 kinds. And you get another matrix So we say that these are row equivalent. Okay, so row equivalent means that you've obtained this matrix by doing one or more row operations, elementary row operations, these three flavored kinds of operations. Okay, so this, and so in this particular case, I have like the picture on our home page where I've got the three planes and they intersect in like one point. But I might be just looking at, say, two planes intersecting, and then I'm not going to get 1 point. I'm going to get an infinite number of solutions, and that's where some mistakes come in trying to handle the infinite number of solutions. And so, so for example, suppose I have just these two planes. And I'm going to use different, just to make the point, you don't have to call them X, Y, and Z. Okay, so now I've got a system of two planes. And so the augmented matrix and if I want to put the sort of indicate the right-hand sides, and it's kind of, I've made this easy to row reduce. So I take -2 row 1 plus row 2 and put it in row 2. So I have 2 -3, 1, 5. That's my recopying. So far, so good. And then I'm going to have 0, 0. And so this is -2 plus 1. That's -1. This is -12. Okay, so this is in row echelon form. Again, well, technically, I haven't defined row echelon form. I'll give the technical definition next time, but the point is it's triangular, so it's going to be easy to solve. So this last equation is minus W equals -12. So that tells me W is 12. So I know exactly what W is. But then the first equation is 2U, it's what I started with, -3V plus W equals 5. And so basically, because there is no sort of leading entry in this second column, I'm not going to solve for V. And so V here is arbitrary. I can take it to be anything. That's why I'm going to have an infinite number of solutions. So I'm just going to call it arbitrary. It's what we're going to call a free variable. And we're going to say these are actually so-called pivot positions because we're going to be able to solve for those.
How do you know that V is arbitrary?
So I cannot, how do I know it's arbitrary? I mean, in theory, I could take I could take U to be arbitrary. I could take any of them to be arbitrary, I guess, except I can't, W has to be 12. But I could actually take either U or V to be arbitrary. But the way we're going to do this, we're going to say, there's a non-zero entry here in this first column, a leading entry in the first column. And there's a non-zero leading entry in this third column. So these are the ones we're going to solve for. In this column, there's no non-zero entry as a leading entry. And so that's the one we're going to take to be arbitrary. Now, that isn't the only way to do it. As I said, I could have made U arbitrary and solved for V in terms of it, but that's the way that's the systematic way we're going to do it. Does that make sense? Thank you so much. Thank you so much. I love questions. I know that I'm not just talking to an empty computer screen. Yeah, I mean, maybe you have some idea how annoying it is to be talking to nobody. Okay, so now I'm going to solve. So this 2u minus 3v plus, so this was 12. That's what I said w was. So I have 2u is equal to 3v minus 12 plus 5. So I have 2u is 3v minus 7. So that's telling me that u is 3/2 v minus 7/2. So that's my solution. And that's actually describing a line in 3 space. This v can be anything. I mean, you can take v 0, 1. I mean, you'll get this infinite number of points by making v all these different arbitrary values. And so these 3 values are describing that line. And so this is in solving these equations, I think this is the more complex, this is the place people have problems, and we'll be doing more of this. And we'll, as I say, we'll actually write down a systematic algorithm for doing it. Right now, I'm just showing you some examples. But handling this infinite number of solutions case, that's what people have trouble with. Because this was an easy example where I just had one infinite, one parameter. I could have many parameters if and so I have to be careful about which things are arbitrary and which things aren't. And that's exactly going to boil down to this row echelon form. It's going to exactly boil down to where I have the first entry. So that's a leading entry. The first non-zero entry is my leading entry. And it's those columns with a leading entry, they're going to correspond to the variables I'm going to solve for. And the ones then I don't solve for, those are going to be my free variables. Those are the ones that are going to be arbitrary. Okay. So, of course, another thing that can happen is I might have 2u minus 3v plus w equals 5 and 4u minus 6v plus 2w equals minus 2. And so when I do this, so this time I get this. Okay, and so now when I write down this last equation, it's 0u plus 0v plus 0w is equal to minus 12. In other words, 0 is equal to minus 12. So what does that mean?
It's not solvable.
There's no solution, because if there was a solution, 0 would be minus 12, which it's not. So this is what we call inconsistent. This is going to happen anytime in this row echelon form where you have where you have your actually augmented matrix and everything here is 0, and then you just have this right-hand side. So that's going to lead to this inconsistent situation, and that you've got parallel. Here we've got parallel planes. They're not intersecting.
Doctor, may I ask something really quick?
Yeah, good.
So the matrix we're doing right now is just to eliminate the variables in the second row, right?
Right. So so first of all, I've taken the system and I've gotten rid of all the variable labels. You know, I'm just keeping track of the places. And so yeah, so what I'm trying to do is I'm trying to get a triangular form. You know, so I've got a so here's a non-zero entry, so I want a 0 below it.
Mm-hmm. Yeah, that makes sense. Thank you.
Right, and so, and we'll, as I said, we'll actually write down an algorithm step by step by step. Right now, I'm just sort of showing you what we will do, but I haven't really in detail defined what this echelon form is, although I'm trying to see what we're aiming for is this kind of triangular structure so that you can solve. Well, you can solve if it's not inconsistent. And so I'm always trying to get more zeros to the right. Okay. Yeah, so maybe this is a good time. So let me just ask one question. So I'm doing row operations here. Could I be doing column operations? Does it make sense to do column operations here?
I would say no, because of that's not the way that the variables are organized in the equations that they represent.
That's right. That's going to screw up the variables. That's like replacing V by 2. Like if I multiplied this column by 2, that would be like replacing V by 2V, and that's going to have a different solution. So here, so we don't do column operations. There will be times, so for example, when we're finding the determinant, that it turns out column operations don't change the determinant. So, I mean, there will be times when we actually do column operations, but not now. So for solving, it's only row operations. Okay, so I wanted to do a breakout group. And I think, I mean, in general, even earlier, if I can break this up like in half, and I have a bunch of problems here, never sure how much time it's going to take. I don't know if you've got your textbooks, but let me actually give you 2 problems to just talk about in your group. So these are ones from that list of, you know, I said they're problems for you to try. So that's from the list. And so one of them is 19, and I think you need to copy this down because I don't think you'll see it once you get in your breakout group. And actually, one thing I forgot to show you, and I will show you, is the whiteboard that you can use in Zoom. So what number 19 says, so it has a matrix that's like this. Okay, so here is an augmented matrix of a system, you know, so it's like x plus hy is 4, 3x plus 6y is 8. And so it asks for what h is this consistent? And maybe let's actually solve one of these. This is maybe not one of them on the list, but see if you can. Let's try number 14. I'm just going to actually write down the augmented matrix instead of the system for you. So it's 1 minus 3, 0, 5, minus 1, 1, 5, 2, 0, 1, 1, 0. You know, so the first equation is like x1 minus 3 x2 equals 5. And so we want the solution if it's consistent. Okay, so those are 2 problems that you can work at in your group. Also get to know some other people. So I always have to figure out how to, so I have to stop sharing. I want, but before, so let me just show you that and let me actually, so now you could bring up the whiteboard too. So in this, so if you go to share screen and you choose, so then you can choose among your screens, you can choose whiteboard. So that brings up a whiteboard that you can write on. So you can write on, if you've got a tablet like I do, you can write. I didn't write that very neatly, but you can write. You can also write with your finger, and I'm much worse at that. It's not great, but it does work. So yeah, so I'm not sure how yeah, my eraser doesn't work. I'm not sure, erasing may not be so easy. Maybe you can figure out how you erase. But so you do have that whiteboard that you can use. And that's a Zoom feature. Okay, so you got some problems. I'm going to give you some time. So I'm going to break you into 5 groups. So I go to breakout rooms, and I want 5 rooms. And so it's going to create, so then it's going to send you to the rooms, and then I'm going to bring you back and see how you did in solving these problems. So also get to know the people in your group. Create the rooms. Okay, so open all rooms. Maybe you have to join. I don't want this. I want to do to come over here. Welcome back, everybody. Great, great, everybody. So that worked pretty well. I meant to also tell you that you can, I think there's ask for help. I think that when you're in the breakout room, I think there is actually something that you can actually call my attention. Maybe sometimes I'll wander through the rooms. This time I actually, I mean, I wanted you to have a chance to not have me around. It's a long 75 minutes. Okay, what about the answers? So when is that system, for what H is that system consistent?
I had trouble on
As
this one.
as long as it's not 2.
Right, that's right. So somebody said you had trouble with that, is that?
Yeah.
Okay, we'll look at that in a minute. What about the solution to the system? X, Y, and Z.
Oh, I got x equals 2, y equals -1, and z equals 1.
That's what I got as well. Okay, so that looks good. Well, let's